In this chapter, we will cover architectural arches and forces and their similarity to a bicycle wheel.
The Romans' inventions were real, and did the bicycle's future reveal? As their legions did march, they built many an arch, and a circular arch is a wheel. You may not see this analogy anyplace else, but I'd like to think of the wheel as a circular arch.
Now, many of these marvelous structures are still standing today. At the top of an arch is a keystone, and the job of the keystone is to take the vertical load from above and distribute it along the sides like this. Let's examine that piece of the arch right there. So here we are just looking at the stones in the arch. Make a copy. Flip one side. And suddenly we have a representation of a circular arch. The circular arch can spin. And as it does, it morphs into a bicycle wheel. So my wheel is really a large number of imaginary keystone-shaped pieces in the rim that are being pulled together by the tension on the spokes. And that is one of those imaginary keystone-shaped pieces right there. Each of these imaginary keystone-shaped pieces is being pulled inward toward the hub from the tension on the spokes, and the resulting strength of the wheel is huge. We can glean one more little bit of information from this graphic, and it's as follows. You can see here that this is a fairly deep section rim, so each of those keystone-shaped pieces is also fairly deep, and the wheel will be correspondingly very strong. In comparison, the rim on the right is made with a rim that is much less deep, and so the wheel can still be strong, but probably not as strong, everything else being equal, as the one on the left. And maybe you can just tuck that little fact into the back of your mind for the time being. Later on, when we start talking about elasticity of spokes and rims, we'll come back and visit that topic and explore it in much more depth.